Let's say we have Java Spring Boot application which manages data about different devices. Also, we have Salesforce organization and we need all the devices' data to be securely synchronized to this org. To achieve this, we need to utilize OAuth 2.0 authorization framework. We will apply client credentials flow, which is ideal for service-to-service communication with no user involved. So, let's begin. To securely access Salesforce resources from external system, we need to create an application that will provide us with OAuth 2.0 features. Salesforce provides two types of such applications. These are connected app and external client app. External client apps are the next generation of connected apps. In general, both of them serve the same goal, which is providing external applications access to Salesforce. But also they have differences regarding packaging and other stuff which is not part of this topic. In the description, I'll provide a link to Salesforce documentation that compares connected apps and external client apps features, so that you could review them and choose the right one depending on your purpose. In our case, both of them are applicable. I'll choose external client app. In order to create external client app, we need to provide basic information: external client app name, API name, contact email, and distribution state, which defines whether application will be packageable. In our case, we don't create package, so we leave the value as local. Enable OAuth. We don't need callback URL since we will be using client credentials flow, but as Salesforce requires it, we will set dummy value. OAuth scopes define what external client can do in Salesforce. For our purpose, it is enough to select API scope. If you would like to read through all the scopes, I'll provide respective reference to Salesforce documentation below the video. Select Enable Client Credentials Flow. Press Create button. When creating users, remember about rule of least privileges. Each user should have the minimum access required for his job. If multiple external systems need to have access to your Salesforce org, as a best practice, create separate integration user for each integration. In our case, we will clone minimum access API only integrations profile. This profile is designed specifically for integration purposes. It provides the least privileges required to interact with Salesforce via API. If you are using any other Salesforce profile, as a best practice, make sure that API-only user permission is enabled. It will allow accessing Salesforce only through API, but not through UI. Also, make sure that API-enabled permission is granted. Without it, you will just not have access to Salesforce API. Navigate to Object Settings. Select object that will be used in integration, provide needed object permissions, and add access to fields. Depending on your security considerations, you can set up other settings like login IP ranges, session settings, etc. Let's create integration user, populate all the required fields, remember the username since we will need it in next step. Choose user license and profile. Now we need to go back to external client app. Press Edit button in Policies tab. Scroll down to OAuth Policies, select Enable Client Credentials Flow and specify username of our integration user in Run As field. In such a way, external client app will know under which user it should perform integration actions. In this tutorial, I will use simple Spring Boot application which I created beforehand. It lists all the device records stored in database. User can go to detail page of specific device. If device data should be updated, user need to press Edit button, provide changes, and press Save. The changes will be stored to the database. I'll provide GitHub reference to this application below the video. Let's register OAuth 2 client in our Spring Boot application. First of all, we need to make sure that we have Spring Boot Starter Security dependency in our POM XML file. This dependency provides core security features and the necessary infrastructure on which Java OAuth 2 builds. Also, we need to add Spring Boot Starter OAuth 2 client dependency, which provides OAuth 2 client functionalities. Secondly, in application file, we need to register our OAuth client. The path to our properties should look next way: Spring, Security, OAuth 2, Client. Here we have two sections: Registration, where we provide credentials to Salesforce external client app, that is Client ID and Client Secret, and also we specify here type of authorization, which is Client Credentials. In the Provider section, we should specify Salesforce OAuth 2 token endpoint. Pay attention that registration and provider should have the same name. In my case, it is SF. You can call it whatever you want. One more thing that I want to mention is that in client credentials flow, Salesforce does not support scope parameter for token request, so all the rights are set up on external client app level. As you have noticed, I haven't specified sensitive information like credentials directly in application file, since I will commit my code to GitHub and I don't want anyone to know my credentials. Instead, I have used variables, so let's set up their values. To retrieve client ID and client secret, let's switch to Salesforce org. Go to our external client app, Settings tab, expand OAuth Settings section and press on Consumer Key and Secret button. You need to confirm your identity. Copy consumer key, open text editor to prepare environment variables and their values. Let's set up value of SF client ID, which we just copied. Go back to Salesforce, copy consumer secret. Set up this value as SF client secret variable. Now let's set up SF token URI variable. Provide HTTPS protocol. Go to Salesforce, setup, my domain, copy value of my domain URL, add this domain to variable value, and add Salesforce OAuth token endpoint. Make it as one string. Copy these variables, go to IDE, edit run configurations. In the environment variables section, paste our variables. Press apply and then OK. We need to have some tools to perform callouts to Salesforce. I'll choose Web Client since it integrates seamlessly with Spring Security OAuth 2 mechanisms. It automatically handles token retrieval, refreshing tokens, and applies OAuth token in the authorization header without additional configuration. To use Web Client, we need to add Spring Boot Starter Web Flux dependency. Let's refresh the libraries. We need to configure Web Client to automatically include OAuth 2 authorization for HTTP requests. For this purpose, let's create Web Client config class and define here Web Client bean. In the parameters, we have injected authorized client manager, which manages all the registered in our Spring Boot application OAuth 2 clients and their tokens. It is responsible for retrieving, caching, and refreshing OAuth tokens. Then we are creating authorized client exchange filter function with passing authorized client manager in constructor. This exchange filter function is responsible for adding authorization headers to HTTP requests. In the end, we are applying OAuth 2 configuration to the web client. Now we can utilize web client in service. Let's create Salesforce integration service. It will be responsible for integration with Salesforce overall. So here we have defined name of OAuth 2 client registration from application file. Also, we have base URL of Salesforce org. This value is taken from environment variable. Let's define it. We should go to Run Configurations. In the environment variables, let's cut off base URL value from SF token URI variable, create new variable called SF base URL and provide it value of base URL. Since we changed the value of Salesforce token URI variable, let's provide respective changes in application file. Alright, also we have instance of web client which is auto-wired in constructor. Upsert record method is creating or updating records on Salesforce organization. In the parameters we pass name of Salesforce object, external ID field, via this field we will be doing upsert on Salesforce, value of external ID, and body. We utilize web client to make patch request to Salesforce as objects REST API. To make upsert, we need to provide name of the object, name of the external ID field, and value of external ID in URL. Then we are telling web client to use SF registered OAuth client for authorization. We are sending our body in JSON format, passing body to request, executing request, getting response in string format, and blocking the execution to wait until the response is sent back, handling unsuccessful requests and returning the response. Let's create device SF integration service. It will be responsible for synchronizing device records only. Here we have device as object name, device as object external ID, SF integration service auto-wired in constructor. Method upsert device takes in device record, prepares body and sends device data for upsert request to SF integration service. Now we can go to device service class and inject here device SF integration service. We have save device method. It persists device record to local database. Let's store save device record in separate variable and return it from method. Now we can add logic to synchronize device record to Salesforce organization. One more thing I would like to add here is if callout to Salesforce is failed, we need to roll back changes in local database. To accomplish this, let's add transactional annotation. Method saveDevice is getting called from controller when user saves changes from UI. Since we have added Spring Boot Starter OAuth to client dependency, by default Spring Security expects that we will be entering the application via OAuth login. To change this behavior so that we could login with username and password, we need to make next changes. Let's create security config class. We will protect all the requests and set up form login authentication. Also, we need to configure a user with its username and password so that we could login under him. Let's run our Spring Boot application and check how it works. On the left hand side I have Java application and on the right hand side I have Salesforce org. Let's log in to our device manager application. Go to all devices. Let's choose any device and try to update it. Device was successfully updated on Java side. Let's check if the device is created on the Salesforce. Refresh list view. Yes, as you can see, the device is created. Now let's try to update the device and see if changes are reflected on Salesforce. As you can see, the device is successfully updated on Salesforce. That's it. Thanks for watching.